with Edibar-Jafaro, that is testing contextuality in psychophysical systems of high ranks. So the studies of contextuality originated in quantum physics in 1960s and independently in behavior sciences under the rubric of selective inference. So let's start with some quantum physics. So two entangled particles are created in a singular state and then separated by a distance. Alice measures one particle along one of the two possible orientations, denoted as alpha 1 and alpha 2. And Bob measures another particle along one of the two possible orientations, denoted as beta 1 and beta 2. This paradigm forms four contexts, denoted as alpha 1, beta 1, alpha 1, beta 2, alpha 2, beta 1, alpha 2, beta 2. I denote the outcome of the measurement made by Alice as A, and I also denote the outcome of the measurement made by Bob, B. So if the particles are spin 1/2 particles, then these random variables A and B have two possible values each, spin up and spin down, denoted as positive 1 and negative 1. This table presents the outcome, the distribution of the outcomes of measurements. The symbols in each cell represents the joint probability. For instance, P11 represents Alice and Bob both get spin up, given the context alpha 1, beta 1. And the symbols outside of the cells represent the marginal probabilities. For instance, P1 dot represents that Alice gets spin up given the context alpha 1, beta 1. Note that if the measurements are strictly simultaneous, the marginal probabilities of the outcomes to alpha 1 is equal across different levels of beta. Here I use P1 dot and another P1 dot to represent equal marginal probabilities to A1 across different levels of beta. Also, I use P2 dot, another P2 dot, to represent the equal marginal probabilities for A2 measured across different levels of beta. So Bell-CH-SH fine inequalities states that these linear combinations of joint probabilities and the marginal probabilities are confined between -1 and 0. If the boundaries are not breached, then these systems can be interpreted as hidden variable model. In our language, it's non-contextual. That is, all the 8 random variables A11, B11 to A22, B22 can be represented as functions of one and same hidden variable. That the probability that A11 equals A12 is 1, and the probability A21 equals A22 is 1, and the probability that B11 equals B21 is 1, and probability that B12 equals B22 is 1 as well. So Bell inequalities can be equivalently represented as a single inequality. Delta C is less than or equal to 0, while the S1 function is the maximum of the 4 terms, and the brackets represent the bracket bracket here represent the expected value of the variable inside of it. Recall that Bell-CHSH Bell inequalities assume that marginals are equal across different contexts. This is so-called consistent connectedness or marginal selectivity. However, in quantum physics experiments, it does not always hold due to possible signaling or measurement bias. In behavioral sciences, it almost never holds. Here I use P prime and P primes and P's to represent the unequal marginals. For such a situation, we need an extended theory to account for contextuality. One such theory is contextuality by default, developed by Dr. Ediba Jaffaro and his colleagues. According to the framework of contextuality by default, the system is non-contextual if and only if delta C is less than or equal to 0. This delta C compared with the earlier one has 4 additional terms. The 4 additional terms takes account of the difference between the distribution of A across different level of beta and also the difference between the distribution of B across different level of alpha. Okay, so if a system is non-contextual, the difference between the distributions of, say, A11 and A12 can be attributed to direct inference from beta to A. And also the difference in the distributions of, say, B11 to B21 can be attributed to direct inference from alpha to B. So this inequality allows us to test the contextuality in empirical systems. Computations shows that certain quantum systems are contextual in spite of inconsistent connectedness. In these 2 articles, we found no evidence of contextuality in several behavioral scenarios, from polls of public opinions to visual illusions, to choice behaviors, to psychophysical matching. All these studies are limited to cyclic systems of rank 4 or smaller. So in this talk, I'm going to report testing connectuality in empirical cyclic systems of higher order, which are 4, 6, and 8. And I will discuss rank 4 system first. So we designed 3 different psychophysical tests to test contextuality. In each experimental trial of each task, the participants were given target stimuli on the left part of the screen. And their task was to reproduce the given target stimuli by controlling a provided trackball. So in the dot position reproduction task, the participants were asked to move the right dot, whose position was initialized randomly to a position that matched the position of the target dot. Okay. And so in the concentric cycle reproduction task, the participants were asked to reproduce the target concentric cycles successfully by using this provided right dot as a center. And in the Fourier shape reproduction task, the participants were asked to reproduce the target configuration by modifying the right shape. In all the 3 different tasks, the given stimuli were always determined by 2 parameters denoted as alpha and beta. So in the dot position reproduction task, alpha and beta can be rectangular coordinates or polar coordinates. For the concentric cycle reproduction task, alpha and beta are the radius of the inner circle, target inner circle, and the radius of the target outer circle. And for the floral shape reproduction task, alpha and beta are amplitude 1 and amplitude 2 of the of a certain polar coordinate representation of the target shape. In some experiments, alpha and beta had 2 or 3 discrete levels, and in the other experiments, alpha and beta spanned a certain continuous intervals that can be later discretized to be discrete levels. And also, I use A and B to represent the random variables in response to alpha and beta respectively. In order to test contextuality, one has to discretize random variables A and B into 2 discrete levels. 4 values were chosen to make this discretization. Each of the 4 values is chosen within the range of the respective random variable. Okay, so this is an example of a cyclic rank 4 system in our experiments. Again, those numbers inside of the cells represent the joint probabilities, and the numbers outside are the marginal probabilities. So for this particular example, it is non-contextual as the delta C is less than 0. We have formed and analyzed thousands to millions of such systems, and we found contextuality in none of these rank 4 systems that we have formed. Okay. So far, I've discussed the testing contextuality in cyclic systems of rank 4. The test can indeed be extended to any arbitrary cyclic systems. A cyclic system of rank n is defined in this way. It contains on n contexts, and 2 entities enters in each context, and each entity enters exactly 2 contexts. The corresponding variables in response to the Q variables are denoted as Z. They are named bunches for each pair of Z's. So this is an example representation of cyclic system of rank 4, and I used this system to I tested this system in my earlier slides. So a cyclic system of rank n is non-contextual if and only if this delta C function is less than or equal to 0. So this is a delta C function for a cyclic system of rank 4 that I used in my earlier slides. Okay, so a cyclic system of rank 6 can be formed in a 3x3 system. Here I present what the contexts, bunches, and delta C functions are in a cyclic system of 6. This is an example of distribution for a cyclic 6 system. The data was collected in our experiments. For this particular example, delta C is less than 0, indicating it's non-contextual. We have tested 10,000 to 10 million such cyclic 6 systems, and we find contextuality in none of these systems. A cyclic system of rank 8 can be formed in a 4x4 system. Here I present what the context, bunches, and delta C functions are for the cyclic 8 system. this is again an example for a cyclic 8 systems. It is non-contextual again as delta C is less than 0. We tested many such systems and found no contextuality in all of the cyclic 8 systems. So in conclusion, no contextuality was found in our data for ranks 4, 6, and 8. And the non-contextuality was found in all the published behavior social data known to us. By contrast, contextuality is present in quantum mechanics even if consistent connectedness is breached.
Thank you very much. Questions, remarks? Yeah,
Yes.
please.
So what about the QQ? The question order?
Question order does not apply to our scenario because, for instance, the dot can be represented as the horizontal coordinate and the vertical coordinate. It's not. The question is asked in the reverse order. But if you consider the dots representing the rectangular coordinates, it's actually different questions. Exactly what we.
Yes, okay.
Any questions?
Yes.
Yeah, so I noticed from your rank measure,
Yeah.
from 4, 6,
Yeah.
8, and the measure of the contextuality is going down from -2 to -4 to -6.
Yes.
So do you have my question that's related to the thing. So, do you have a scalability type of analysis about how your measure is sensitive or stabilized?
I think one answer could be we have measured like millions of such cyclic systems. We found no contextuality in all of those cases we have investigated. And
No, I'm talking about the scale of your measure from -2, -4, -. So if you keep on going, the rank is getting higher. You may get -10, -20 or something. What's the range of the sensitivity of the measure?
I guess as the rank is increased, the effect size is also increased.
This is not a measure of contextuality.
Okay.
It is simply whether the inequality is violated or not.
Okay.
The value itself is irrelevant.
So measure the absolute value of this measure is irrelevant.
Is irrelevant. Right. It can be related to real measure of contextuality, but it is not what she is reporting.
So you didn't calculate this one?
The sensitivity, no.
I mean, the measure of contextuality.
No, it is very new,
I know. Yeah.
newer than this research.
Are there more questions?
May I just answer Louis? I think Louis was asking you about the QQ effect in relation to your statement that all published data did not exhibit contextuality. And the answer is that QQ effect is, if it holds, necessarily implies non-contextuality. So to the extent QQ holds, there is no contextuality in question of the system.
Yeah, we actually analyzed that data in one of our publications.
Yep.
We found no contextuality, even Q2 hold.
Okay, thank you very much.